Hello and welcome back to Learn It from a Layman. I am your host, Carl Christensen, back with Tim, the computer whisperer Cox.
It's true. I
It,
can whisper at any computer you can bring to me.
and yours is more like quiet muttering. It's not like meaningful whispering. It's
Yeah, kind of aimless, uh, half angry.
exactly. You just picture a grandpa at a computer, like muttering quietly to himself. You've got
That's
Tim.
right. I could. Oh, why's this thing not working? What's going on? No.
Yeah,
That's
maybe
right.
less whispering, muttering. Anyway, whatever. All right, today we're going to be discussing the basics of programming languages. So we've done the basics of computer science before. We've done object-oriented programming. Let's see, we did browsers. We've done a number of computer-related subjects, but this one is I think it's important for the layman to understand just some basics about uh, programming languages and how they work, if for no other reason than if you need a second job or a side hustle. It turns out software is in demand. So the first topic here, I guess, is just a basic understanding of what computer languages are and what they do. And then for that, I think we need to kind of picture something, I guess, that we're all more familiar with is like directions and locations. So if you're going to the store, you're going to a different city, you're going to be getting directions. And if you are used to getting your directions these days from like Google Maps, you'll expect them in a particular format. You'll expect it to say, keep driving on this road for 3 miles and then take a right turn on such and such a road. Uh, you know, get in the right lane. Anyway, you'll expect a particular format of directions, right? Um, and that format is different than the format you would get if you were, for example, getting directions on how to fly from one city to another city. That is a format I'm entirely unfamiliar with. Tim, you don't fly, do you?
Oh, yeah, not as often as my publicist would like.
Significantly more than you're qualified for, though. Um, I'd imagine that pilots have a particular way of giving directions and a particular set of instructions that they're used to getting, right? So directions can be different depending on the format, the mode of transportation, for example. Let's take another example, and this like cooking recipes, right? Um, I'm not much of a cook, Tim. What format do you expect when you're cooking for like a recipe to be in?
You expect a list of ingredients and then a set of steps to follow. So presumably you use the list of ingredients to compile all the everything you're going to need, and then a numbered series of steps that you follow in order to make the food.
Right, right, and I'm guessing once again I've had very limited exposure with this as well, but if I'm cooking in Europe, right, let's say I'm in France cooking,
It
I'd
will
expect
taste better.
the it certainly will. Well, actually, I'm not sure that wherever I cook has no influence on. It's the individuals in France might make better cuisine than the individuals in the neighborhood that I'm in. But um, I'm imagining that the recipes that you see in, say, Paris are going to be in a slightly different format, if only in right the measure, the unit of measure, right?
Hmm.
Um, and so that's another scenario where this is what we're doing is we're looking at different ways to encode information, um, specific types of information, and how that can vary depending on need and location and all those types of things. One other example before we move on to how this relates directly to programming languages is a syllabus, right? Tim, you write up syllabi.
Yeah, good job using that Latin plural.
I use it all the time.
I'm trying to
Uh,
think of a joke involving Latin plurals, but it escapes me.
yes, it would. Um, the syllabus is is a bunch of information that you need to get to a student, and I guess in your case also parents, right?
Mm-hmm.
And is there a particular format that you try to follow? Is there a particular suggested format from your school? How do you get the syllabus written up?
Yeah, the syllabus, I think there's some flexibility. I suppose with most of these there is some more than others, but yeah, you generally have the kind of the purposes that you want the document to meet. So you include contact information so that you can prepare the way for contact throughout the year, expectations, materials that students expected to have, rules, and so forth. And so you have kind of these different categories, and each one with the crucial initial information that you need the student to have and the parent.
Right. Yeah. So I'm guessing that your middle school syllabus looks a little different than, say, your college syllabus, right?
Yeah, surely.
So, that's another just example of how specific. I mean, the end result in your middle school class is pretty similar to your end result in your college class, right? You're going to be giving points out for assignments and end up with a grade.
Mm-hmm.
And there's going to be different assignments along the road that get you there, different tests and exams. But the way that you encode the information depends on the target audience to some degree.
Yeah.
And so that will take us then directly to programming languages. So each one of these other examples is a scenario that I think the layman is more comfortable with, more familiar with, where programming languages seems to take it outside of the world of the familiar into the unknown, and that can be hard to relate with unless you can take it into these terms of, okay, well, I know what directions look like, I know what a recipe looks like, I know what a syllabus looks like. Programming language is a similar type. It's just an encoded direction. In this case, you're encoding the information for a computer. But computers can do lots of different tasks, right? And so that's why we have different, and we'll talk about different variety of programming languages and how they work. But at a basic level, and I think a very important level, you need to understand that that's what it is. It's just a set of instructions. And so one of the most important things to remember as we start talking here about the various types of programming languages is programming languages cannot be ambiguous. And that's something, I guess, one way they differentiate from these other types of encoded directions that you're more familiar with, right? A syllabus, Tim, I'd imagine that every once in a while there's a little ambiguity as to what a syllabus, even the perfectly written up syllabi that you do, maybe there's every once in a while a little bit of question from a student as to what exactly did you mean here, Mr. Cox?
And frankly, sometimes that ambiguity is intentional and even desirable.
Sure. Right.
It allows you in some flexibility later on in in how you are interpreting and applying that rule or expectation.
Right. And so in the syllabus, some ambiguity and can be quite useful. Cooking, maybe a little bit, right? A pinch of that, a touch of that. Maybe you want a little bit of ambiguity
to taste, right?
Right,
salt
exactly.
to taste.
Right. But in driving directions, ambiguity is incredibly frustrating. You don't want Google Maps to be like, and take a pinch of a left turn here, or take a left turn when you
get
feel
into
like
the wrong line to cross the U.S. border.
Oh my gosh! All right, I may have had an unfortunate experience with Google Maps and the U.S.-Mexico border. We'll visit that at some future podcast.
But don't worry, Google. We will still let you sponsor us.
As soon as they fix that. Until that, I'm boycotting. Okay, so with like directions, computer languages, you just and even more rigidly than directions, there can be no ambiguity in computer programming languages.
Can I give an example that I think might be familiar to some listeners? If you in English class ever were asked to, so if you've seen the um, assignment where the teacher says write up instructions to make a peanut butter and jelly sandwich, and then you deliver the instructions to the teacher, and then the teacher follows your instructions to the letter precisely as you wrote them, usually to disastrous effect because you didn't properly think through the steps. And so you say put the peanut butter on the bread, and then the teacher just puts the jar of peanut butter on the bread, and and so and
Right.
In English class, the point is to emphasize clarity and precision and so forth. But this I think is instructive for what you're saying about computers are kind of like that teacher, bent on interpreting exactly without any variation exactly what you said. And if there's any ambiguity, where as you're noting in a social context, there's so much context and so much understanding between people that what is intended can easily be bridged over ambiguous instructions. But with computers, there is all of that social context and understanding is stripped away, and so your computer acts like that teacher that refuses to do anything but exactly what you say.
Right. And built into human languages is ambiguity, like essentially like you're saying, like put the peanut butter on the bread. Well, I can put the jar of peanut butter on the bread, and per the English language, I have fulfilled one sense of that word, of that phrase, or that command. But not the spirit of the command. But that's the human languages have ambiguity built in, which hence the need for programming languages that can be written in such a way that there is no ambiguity, that a particular instance of a set of characters has only one meaning. It is pointing to one specific location in the computer. It has one specific function, and that's why programming languages are not natural language. There parenthetically have been attempts to make some natural language computer programming work. I'm aware of it from a long time ago when I was in college, that there were efforts going on to make natural language programming a thing.
Sounds fun.
And to be fair, I don't know how far along the road they got. I don't know if the efforts are ongoing, but it's not. You essentially still to remove the ambiguity from human language is to make it not human language anymore. And so you can't have a pure natural language as a programming language. It's not possible. Not in the actual sense of what a human language versus a programming language would be. So, okay. But that is the idea behind programming languages. That's why they exist, and that's ambiguity is a no-no. Can't have it. Isn't a thing in a programming language, because in programming languages, or at least, well, we'll discuss in a second the difference between scripting languages and compiled languages. But in a lot of cases, computer code, when I finish the set of instructions, I have it. I have something. It compiles, which is just another way to essentially to distill that information that I have coded in that programming language into a format that is more purely machine readable, right? Programming languages still maintain the ability for humans to be able to interact with them at a pretty high level. That I can look at it, I can read it. There are words, even if they're jargon-esque, if they're specific to a computer scientist. I don't have to speak computer per se. I don't have to read ones and zeros. This isn't the Matrix. So there are words, and so we're going to take that information to compile it down to assembly, or we're taking it to a more machine readable format, and that's and that compiler is the one that you can't have any. No ambiguity there. Everything has to be written out, have a specific meaning inside this language. All right, so scripting versus compiled languages. So this has gotten a little fuzzy, as a lot of computer science has over the last 10, 15 years. Generally, the idea here is that some computer programming languages are scripting languages. Now, we've actually discussed this. I think we discussed it a little bit in our basics of computer science podcast from 2 years ago, where we talked about scripting and languages. But I think in that case, maybe it was the object-oriented programming podcast that we did. But a scripting language is a language that is not compiled. It is the idea is that it just lives in that format, and then the computer has a way of interpreting it directly from there's a set of commands in the computer, a framework that will take that and use it and interpret it without the compilation process that takes the information out of the actual instructions that the programmer wrote to that intermediate step of computer readable file formats. This one just has, it's, for example, for those of you familiar with JavaScript, that's generally the one most people have some basic familiarity with. Sometimes you see JavaScript. You'll see it in your browser occasionally, usually when something breaks. And JavaScript is a good example of, not always, but like I said, things have gotten a little fuzzy, but that's an example of a script language where as a software engineer, I write the code in the language JavaScript. Okay, so I write some code. I finish up my little instructions. That's what the code is, right? And so now, if I'm making a website and I'm including that JavaScript, there is no step. There is no compile step there. I can put that directly on a server. And once again, if you want to more about the servers and how that all works, go back to our other podcasts. I put that on the server, and that gets directly consumed by, Tim, your computer. Your computer then grabs that JavaScript file and it interprets it. So on your computer in Chrome or whatever browser you have, it will take that JavaScript and it will work directly with that. It'll interpret it there at that step. So there is no intermediate step where other code such as Java, which is another programming language, so don't get it, there's JavaScript and Java. Java is a compiled language. So I, the software engineer, write up my code. I have a library. I have a set of commands that I've got it to do. And then I compile that. So that will go through the environment that I'm on will go through with using this compiler, this framework of rules, and to take that code that I wrote and turn it into a different format that is not human readable, and that is then what you interact with as the user. As you know, you're not directly interacting with the code that I wrote in the form that it was written. You're interacting with it in that compiled format. So that's your exe files. Those are executable files. That's your compiled file format. Does that make sense, Tim?
Well, I'm going to say yes.
Do you know what an exe file is?
Is exe for execute?
Executable. That's an executable, right?
Executable,
so,
okay.
So most of your programs that you run on your computer, including your browser, is running from some type of executable. And that is an executing commands, thus an executable. And that is a compiled piece of software, whereas a script is just, hey, Tim, I'm going to shoot you a file. It's got some code in it. You can just double click it, and something on your computer will do the interpretation of it so that it'll run the commands that I sent. But you could actually open the file and edit it because it's not compiled.
Okay.
If that doesn't make sense, then I need to do a better job. But this is learning it from a layman, so that's the best job you're going to get.
Well, it certainly gets me along the way. So,
Okay. Let's see here. So that, like I said, it's kind of gotten a little fuzzier over the last 10, 15 years, where scripting and compiled languages can kind of go both ways. You can actually compile JavaScript and run from that. You can sometimes take what are generally compiled languages and kind of use them in a more script-like way. So that's, once again, the idea that as if I wrote a script file, the idea that I can just pass that off to different people, different locations, put it up on a file server, people can grab it and use it locally on their computers and have their computer directly interpret it. That can be done that way, or you can actually compile. Anyway, it's JavaScript and all these other languages that we'll talk about here in a minute. I've kind of started blurring that line because there are different advantages and disadvantages to compiling versus scripting. Just very briefly, the idea that a compiled program has already gotten it down a level, right? It's already interpreted some of that code and put it in a format that is more quickly accessible by there is no interpretation needed, no compile step necessary in order to execute the program. So that's going to be a little quicker versus a scripting language where obviously you're working directly from what is more or less human readable code, and so you need there's another process involved in order to get it to a format that can be executed directly on your computer.
okay.
But that the enthusiasm with which you said okay makes me question everything that I've said for the last 10 minutes.
No, it is. I'll be honest. For we'll say an outsider with limited background, it's a lot to wrap your head around. But we're getting there. Let's forge ahead, and
okay.
People in my boat, if we need to give it a second listen to kind of suction in the rest, we can do that.
Okay. All right. Well, hopefully it becomes slightly more clear as we move along here, and yeah, maybe you can go back and re-listen, and maybe it makes more sense the second time. There's a possibility it makes less sense the second time.
That's true. The Alice in Wonderland effect.
Yes. All right. So I want to, before I move on to the next thing, I do compilation. The word compiling and compilation, that is also kind of, that's something we're familiar with a little bit in the layman sense of I can compile documents. It means like, oh, I take something from here and here and I put them together. And that is kind of what we mean in the programming language sense, but it's also a little different than that. I think another way to look at it is essentially we're doing a massive find and replace. We're taking this big chunk of code and we're saying, oh, this has this element in it, which can be replaced with these encoded bit. This smaller piece of information can represent that. And oh, this right here, well, we can just point that to this other piece of information. And so it's taking all of that and just finding and replacing everything to the point that the computer is being able to recognize it as more computer specific instructions, where it's specific sets of characters, pointers at particular memory addresses, that type of thing, as opposed to these chunks of code that I've written up. If that makes anything slightly clearer, if you can just picture it as finding and replacing.
That comparison does help.
Okay.
Something I'm familiar with.
Okay, perfect. Yes, you can imagine just a whole load of finding and replacing to make it less and less, well, I mean, it's compiling it down. You're making it smaller and smaller and smaller. So anything you can do to replace bigger stuff with smaller stuff, that is
it makes the process more efficient. Is that kind
right,
of
exactly? Yep.
Okay.
And very specifically tied to a particular framework or computer. And so that's another step in this compilation. And that'll move us on to kind of another topic is the scripting can be done across different operating systems, right? The idea that I'm on a Windows machine here, but I'm writing code that will be used on Android, right? On your phone or your iPhone or your iOS. And if my computer compiles, so it does a bunch of find and replaces to make sure it specifically works for my computer. And then I say, okay, go run that on an iOS, on an iPhone. Well, the iOS will look at that and say, no idea what that means. That's not encoded for me. And so that's an issue with a compiled program, is that all of a sudden you can get it in a format that was specifically telling the computer that you were running on, or the framework that you were building on, which in one low sense is just the operating system. Oh, this is how you run it. That's what you're finding and
So is that why
replacing, all
when
that
you're on
stuff.
a certain kind of device, certain like apps or sites, you just can't access them,
Right,
or
right,
they have problems?
right. Yeah, if you're looking for an app, for example, and you're really frustrated because it's on your iPhone, but your brother has an Android, and you're like, well, why doesn't yours have the same app? Well, I mean, there could be a whole host of other reasons, as far as like, how much they're charging for the marketplace anyway. But one of the very fundamental reasons is if the app was written in a language that was compiled for iOS, then they would have to do some significant work, or porting. Porting is essentially the changing of a computer program from one language into another. Um, so translation also, I guess.
Hmm.
The that work, in order to make it work, make their program run on a different type of framework, a different operating system, which is going to interpret those commands. Those commands are just different. The underlying commands for point this piece of memory at this piece of memory, or when you see this, do this. All those other, when we've already done the find and replace specific to a particular computer, that computer gets to find and replace and say, oh, this is what it means here, and this is what it means here. Then now when I pass that off to a different computer, it's reading gibberish. And so that's an important differential between compilation and scripted files don't suffer from that, right? Because I'm handing you a piece of information that has not yet been interpreted. It's just coded for that language. And so I can pass it off from a Windows machine to a iOS computer, and or we're good, because that's all the information is there and not specific to a particular operating system or not particular framework. And that's, well, I guess the next step is a framework. And I don't want to get too, this is kind of moving away from what the layman even necessarily needs to know. An operating system is one thing that we can mean when we talk about frameworks. Something that you may have heard about. So Microsoft, aside from Windows, has their own framework of code. And I guess a good picture for this is, imagine an expansive library, right? Go to the biggest, the Library of Congress or something like that. And we're talking hundreds and thousands and potentially a million books, right? Just so much information. And so if you're there to write a book report, or to compile a report on a particular historical individual, say Abraham Lincoln, are you going to have a whole host of information available to you? Yes.
Yes.
However, if you go to your local community library, the amount of information available to you about Abraham Lincoln, well, probably sufficient. Well, maybe you'll have to do a little bit more, uh, you know, digging, or you're just not going to have the same tools at your fingertips. And that's the idea of a programming language framework, is that a lot of these coding, and I think I've said this in other podcasts in the past, these days there's a lot of not as much invention these days. So obviously, there still is. It's a lot more innovation. The idea that I'm taking a lot of existing code and I'm using it in new and innovative ways. I'm combining it in new and innovative ways, because obviously, as you can imagine, over the last 30 years of I guess at this point, more than 40 years of programmers out there, they've written a lot of very useful things, and these vast, extensive programming language libraries exist, where instead of having to write up a original paper on Abraham Lincoln, I can now just say, okay, well, I want some of what that report says about Abraham Lincoln and what a few of those ones say, and I'll just put them together, and then I'll add a couple tidbits about the city that I live in, which Abraham Lincoln happened to visit once, and nobody's really talked much about that, right? So all of a sudden, you've got a innovative report, not an inventive report, right? I guess history reports probably shouldn't generally be inventive.
Well, it depends on your purpose. You really want to.
Hopefully you're not inventing a history.
It's more common than we might care to admit.
That's true and unfortunate. Yes. Okay. So that's the case with code as well. And that's what a coding library is the idea that inside this programming language that I'm using, I have a vast network of resources. And so if I need to do a specific task, instead of having to write it myself, I can just say, hey, you have a, does this framework have this specific command? Oh, it does. I can use that. But these networks, frameworks are often specific to a particular, once again, type of computer, right? Android, iPhone, Mac, Windows, Linux, all these different types of operating systems. And so if I want to use a particular command, a particular library, it has to be accessible on that computer. And does that library work on that type of operating system? Well, maybe and maybe not. It depends, right? And so that's something that programming languages are kind of built inside that milieu. Is bless me, by the way.
Did
Sorry.
You just say milieu?
I did.
Good job. That's 10 points to Gryffindor.
I'm not Gryffindor. If I were going to be something, I'd certainly be Hufflepuff.
Respect. Hufflepuff, it doesn't play well in front of Hollywood, but everyone wants a Hufflepuff around.
Yeah, I mean, Hufflepuff is so maligned and misunderstood.
Yeah.
We should do a podcast on Hufflepuff.
They live in a milieu of darn it, I'm sorry, I got nothing. I ran out just digging out that French.
Yes. Anyway, so programming languages kind of inside this environment of networks of libraries, frameworks that are built on top of these operating systems. So you kind of have these these stacking stones that you're building on, and if you pull one of these out, everything breaks. And so that's
Can I start like tracking all the metaphors that you use? I think that would be a fun little, ping, a new metaphor.
Yeah, that's probably
they're great.
why
They actually really help a lot. So
well, good. That's good. I'm glad. Because I don't know anymore if any of this makes sense. I've been in this world for so long that sometimes if you've been in a particular mindset for so long, you can't connect, and that's the danger. That's why learn it from a layman was supposed to be learning it from someone that didn't know much about it. Unfortunately,
yeah, really, I should be explaining this to you.
Yeah, you should be. Well, this is your job, Tim.
So, Carl, the computers use electricity. And there's little zaps that go this way. And
yes, exactly. Perfect. Little zaps. I think that's perfect.
All right, and I'm done.
Okay, so we've talked a little bit now. So now the layman is probably wondering, okay, well, you're telling me about all these frameworks and operating systems and why this programming language can't go on that operating system, but why? Why do we have all of these in that case? Why don't we just have one operating system that can host one framework, which can host one programming language, and we're all good? And then we don't have to
Oh,
deal with
wait.
all this junk.
Is this where I introduce conspiracy theories?
Please do. This is
All right. This is so the man can milk us by making
right,
us jump into different, operating systems and
because the world is flat,
check.
Tim. Very
Yes,
simply.
that's right.
No, the reality of it. I mean, part of it is kind of the fragmented way that the market has come together over the the course of 20, 30 years of just trying to figure out how to do this. But part of it is not necessarily the fragmentation or lack of communication. It's really the different needs, and that's why we started off with the idea that directions are different for someone that drives a car versus someone that flies an airplane. Directions are cooking is different. If you gave me a recipe, you're gonna be darn well better spell out every single thing you need, right? Whereas a sous chef is going to need very different type of directions on how to cook something.
Sous chef. And more
Yeah.
French.
Right. Mon chien est fromage.
I would take a cheese dog. Ooh, that's like at the baseball game. You get like a chili dog with cheese. I must be hungry.
Yes.
Sorry.
Okay.
Notice we are doing a lot of like food comparisons here. French cooking, peanut butter and jelly, cheese dogs.
Oh my. It's funny because I keep on almost losing literally where I am and what I'm talking about. Like for a second there, I couldn't remember whether or not we were talking about France for the podcast or what. But
that means I'm doing my job.
Programming languages and why the different variety exists is because in a lot of cases we're doing different things.
So explain those different things. Like, what do you mean?
Well, so let me take the very basic one, and this is kind of revisiting some of the things that we've talked about in the podcast in the past, but the idea of a Windows operating system, a iOS, that's a Mac operating system, and a Linux operating system. The layman has probably no familiarity with Linux, but that is also why Linux, as a computer scientist, or at least as a web designer, or I don't need a lot of the stuff that the layman needs on their computer. I'm not running word processing. I'm not necessarily surfing the net. But I do need a different set of tools on it. I need the ones that will help me execute my job as quickly as possible and be very friendly to all the permissions that I need to set up and the way I need to host the files and all that type of stuff. And so I don't want the same stuff. I don't want your basic how to drive to San Diego directions. I'm in Paris and I'm going to fly, and your little directions on how to drive there are meaningless. I need a specific set of directions that will help me in my job, and so that's the idea behind these different operating systems. Is we're doing different things, and on iOS, it's very much like a Tim muttering person needs very specific help and process to get through their computer. I don't want a lot of control. I just want to be able to do the jobs I need done, and I don't need to worry about I want to worry about the rest of it. Windows kind of straddles that, which is kind of its strength and its weakness. Is it sometimes it wants to play the more programming language friendly, software engineer friendly side of things. Sometimes it wants to play the more end user side of things. But that's just one example of how we use different tools in the computer for different groups of individuals. And then you can imagine applying that across all these different variety of tasks that we put computers to. I don't if I'm doing just a bunch of calculus problems on the computer, I don't need I don't want a bunch of framework code that can do that write music. Like, how is that useful to me? All I need is a bunch of math operations. So that's why there are different languages, and we'll talk about a few of those here in a second. We're going to move to that pretty soon here. But does that make sense, Tim?
Yeah, I think so.
Okay.
Would you say that it's still true that the diffuse nature of a free market also is a factor in why there's all this difference?
Certainly, there's no question that plays some role in it, because there are essentially directly competing frameworks and computer and languages that essentially fill the same niche, and so in that case, yeah, they're the same, and then it's just the market, people trying to one up each other, and as an end user, we generally benefit, but not always. We try to look on the positive side here, as far as saying there are good reasons why different variety of languages exist, and then there are sometimes frustrating realities that come as a result of that. All right, but let's talk about a few of these languages. And I guess the reason that I'm going to list this is mostly just so that if you're looking to use a language or become familiar with a particular programming language, you can know which one to become familiar with and why you might want to do that if you want to, for example, want to get a job or just open up your prospects. So this is the ranking of the popularity, I guess, of programming languages. I've got two lists here. I actually have three lists, as there are in all things. There are different ways to rank this, but I'm just going to go through a few of these and kind of let you know what they are and why they might be useful. So one of these rankings has the language Python as the first most popular language. Python is I actually don't know when it started. Its popularity has certainly spiked in the last 10 years or so, I'd say. It is a language that can be used in a lot of different contexts. I think at first it was a scripting language. It's now something that you can compile as well. Like I said, the lines blur, but it can be used web. It can be used as a foundation for an executable, which is like the programs that you're running, like your word processor or whatever it might be, your browser. So Python is I think a good solid language to become, if you're just learning, that's a good one to try to pick up. It's not too esoteric. It's always seemed ironic to me that the word esoteric is esoteric.
That's its downfall right there.
Right. So it's not too like specialized and niche, that it's something that I think the layman can start grasping pretty quickly. The second one on this list of popularity is Java. This one has been around for a long time. Java is still used in a lot of major enterprise applications. This is a compiled language. This is some like I said, some blurring of the line, but a compiled language, and it is a foundation. So when I took my first CS computer science class in college, they taught us Java, and so this is a good solid one. A lot of resources out there, a lot of job opportunities for Java as well, and that one's once again just as a compiled language, but it's all pretty ubiquitous. JavaScript is number 3. JavaScript, we've already discussed here. This is generally, as the name would imply, a scripting language, which means generally scripting languages, for whatever reason, kind of have more layman appeal, because you don't have to understand the framework behind it as much. You don't have to get a whole program compiling. It's just you can write a single file and it can run that. You don't have to worry about anything else. So that if you just want to dabble JavaScript can be good, and JavaScript because of its just well, I guess its web friendliness has become one of the most um, you know there are so many different flavors of JavaScript, which means there are lots of different frameworks that use it in different ways, and so it's very powerful in that way. And I would recommend becoming some. And if you want to do any web work, you need to be familiar with JavaScript. Number 4 is C
Now,
sharp.
explain to me.
Yep,
Oh, I
shoot.
was going to say, explain to me JavaScript and Java. Like what?
Right. Well, I mean, I think that the names, I don't know the exact history of how that happened, but I think the names probably uh, tell a pretty good story. JavaScript, meaning, oh, I want a script language. I just want the file that can be delivered to different operating systems, and we can handle it on those systems, as opposed to Java, which is doing that compilation. So if I want something lightweight, quick, a single file or just a small group of files, then I just want to be able to deliver that and have the client, whoever grabs that off of the browser, work with it. That's JavaScript. And I'm guessing that's why it was developed to begin with. Is Java is this whole framework, like what I was talking about, this whole huge library of, oh, you want to be able to patch, anything you can imagine. Java is going to be able to give it to you. It's been around for so long. Um, and so you don't want all that overhead. You don't want all that compilation nightmare. You just want, here's a file. And that's what the JavaScript is. Does that make sense?
Yeah, yeah, I think so.
Okay, so then the last one, I guess I'll talk about one or two other ones, but this is my pet one because this is the language I've used pretty much for my whole career, and that's C sharp. This is one of those scenarios where Java and C sharp are the same niche. They do the same thing. I'm sure there's someone out there that's yelling, no, that's not true, but they pretty much do the same thing. And I guess Java historically has been more operating system agnostic. You've been able to use that in iOS, or whatever, where C sharp historically was it was a Windows Microsoft developed language. And so, as you can imagine, specifically to available and used on Windows. That's no longer the case. Microsoft's working to make that more friendly to everyone, and they've been working on that now for like a decade. But that's one I've used for my whole life, and that is well, my whole life. C sharp is younger than me, but it is one that you can have there are a lot of jobs out there that use C sharp. So if yeah, anyway, I
Really
will leave it
curious
there.
about the name for that one too. You know anything about why these are? Well, all of them: Python, C sharp, Java.
I don't. Yeah. So Java, I'm guessing, has something to do with just coffee and computer software engineers working late into the nights, drinking coffee, and therefore Java. That's my guess. I don't know. Maybe I did at one point, but I don't remember. C sharp, I think, is just a riff on another older programming language or languages, and that's the C class of programming languages. That's C and C++. Those C's been around since, I don't know, maybe the 70s, maybe early 80s, and that was a very early programming language that had and these early programming languages, you just don't have as much framework in there, so you have to do a lot of these computer specific operations yourself. Like if I want to use memory in a particular way in C, I need to say that. I need to say, and this code will use this much memory, and when I'm done, I will get rid of this memory. That's no longer the case in something like C sharp and in Java. That memory stuff is essentially done under the hood, just like computers nowadays, just like cars nowadays. You don't have to worry about the same things that you did 50 years ago. That's the way with software as well. And so C sharp, I think, is a riff on the idea that we went from C to C++ to C sharp.
Okay, cool.
That's my guess. Is it kind of iterative. All right, then let's talk one or two other ones. So R, I think it's come up when we had our basics of data science with Mike Vidomsky, Dr. Vidomsky. Um, that's a very statistics heavy, math heavy language. Very useful in data science and your heavy math fields or statistics fields. So that's a good example of why you have a different language for a specific tool set. It can do a little bit more than that, but that's essentially what it's used for. And that's on the list here as number 7. And so if you have a background in statistics and you've never learned R, I'd imagine that would open your job prospects significantly. Let's hit one or two others. So we've got any query language. So there's something called SQL. There's a bunch of different query languages, and query languages are ways to essentially write a command to grab information from a database. So in the case of SQL, that is a structured query language that essentially is a way to say, okay, I know that there's data in all this database, just holds all this information, right? And I want to be able to grab it in a particular way. So I want to say, okay, grab this piece of information and add this piece of information, but don't include this piece of information and show it to me. And that's your query language. So your structured query language, there are other query languages that essentially just grab data from a particular database and give it to you. So we're not that's a kind of a prerequisite for a lot of computer science. One other thing, last thing to touch on in this case is markup languages. So your layman out there is familiar probably with HTML. That's hypertext markup. Yeah, hypertext markup language. There's something called XML, which you may have heard of before, which is just extensible markup language, which just extensible as in extension, as in I want other stuff. So a markup language, if you look at view your page source and go back to our browsers podcast and listen to that, you can view your page source and you can see your markup language for your website. And it's going to look like just someone barfed on your screen, but it's going to be a bunch of tags, these angle brackets around structured pieces of information, and in between those are your text, your image, reference links to particular information that they want to pull, and so that's your markup language is a way to structure the text in a particular way and mark it up. So hypertext, so idea of hyperlinks and that type of things, bringing that to bear in a website and a web page. That's where HTML is, what it is, and that's HTTP, which is the protocol, which is how we transfer that information, that media across the web. And then XML is the idea of, well, HTML has particular tags defined, but I want all this other structure and it doesn't exist. Well, then I'm going to make my own rules. And there's a rule. There are rules to make rules. So we won't dive into that too much, but XML is a very powerful way to structure data in a particular format so that it's better machine readable and very unambiguous, I guess. All right. Any questions, Tim?
Would you recommend for let's say, the average layman or laywoman, schools are trying to kind of tilt the heavily male-dominated nature of like, the tech sector to girls. So
Sure.
anyway, but what would you recommend for if someone just wants to start? Like I've seen and even fiddled around a bit with code.org, which I think teaches HTML. Would that be a good place for, let's say, a kid or say an adult out there who just wants to kind of try it out, maybe not ready to drop a bunch of money to take a college course on it or something like that, but where would be a good place to start?
So I think the Khan Academy probably has
Oh
some
yeah.
good. I've seen it before. I'm trying to remember if it was on Con where I saw it. There are good like structured ways that will start you very basic. You want your drag and drop coding where you just kind of get to see it, but you don't have to write it at first. And I think Con has that there. It's been a while since I've learned, so there might be newer tools out there that will teach you programming. I One of the things I guess for the layman, sometimes you get these weekend schemes. If I'm going to learn how to code over the weekend, and then it just blows up because it's like, well, it turns out that's significantly harder than what 2 days will afford. But I think one of the ways to try to get a specific thing that you want to accomplish and then dig in from there. And so, because a lot of people don't, if I've graduated school, I don't want to go back to school. I want to accomplish something. And so and if that task is sufficiently motivating to you, then you can use that as the impetus to get the skills that you need in the language. And so a way to get some people there's a website called Leet Code. Leet Code is like a lot of kind of either coding puzzles or riddles, those types of things, where you need to be able to code something up. It's not really a starting point as far as it doesn't teach you how to code, but it gives you kind of motivation to code. Is like, oh, how can I solve this problem? And then you can figure out, okay, well, what do I need to solve this problem? And I don't know, that would be one way of taking it, but yeah.
And just going off of that, from what I understand, a lot of writing code is I know people who teach writing code, they look at it from the perspective of we're solving problems here. We're using logic to
Yep.
to problem solve.
Right, exactly. So
Okay.
And that's kind of the final takeaway here is programming languages. Again, take ambiguity out. This isn't it's very much a different mindset than the humanities type of approach to language, and so it's a very mathematical approach to language. But I think it's useful, even if it isn't your cup of tea, is to just kind of understand what it's used for and how it impacts your day to day. Which hopefully we've made some useful relationships, tied some really useful relationships for you.
And I'm glad you brought up the humanities, because that leads us into our Learn It From a Layman next sponsored listener contest, which is the coding poetry contest. So everyone is eligible. You can just send us your poem written in either Python or C# or JavaScript, any coding language, and we'll select the winner and send you a pie.
No, we won't.
Maybe.
All right. Well, that brings us to the end of this, and another teaser. Well, I should have done this earlier in the podcast, but we've got the next episode is episode number 100, which is a big deal to a few people.
Important people.
Exactly. And Tim will be leading that on some yet to be determined topic, but it will be awesome. So tell your friends, and let's spread the word, and go ahead and listen to all 99. You got to binge all of them before you listen to 100.
Clearly. Yeah, the big lead in. It's kind of like when you go back and watch the director's cut of all the Lord of the Rings, kind of like that. Not
really, but more like when you read all the toddlers writing before they get to first grade.
That's right. Heartwarming.
Exactly.
Kind of cute, adorable. Oh.
Yeah, exactly. Look how much progress they've made.
That's true.
All right. Anyway, well, thanks, Tim, and everyone's listened, and we'll be back again soon for the 100th episode.
Adios.